we need to think about why Paris could work in a different way. And I'm going to suggest to you that that way is what's called experimentalist governance. So the front line, the top line here, I think we all know what those words mean. The bottom line, they may not make a lot of sense, and hopefully by the end of my talk they'll make more sense. And I think this is the new frontier of thinking about international cooperation in this domain. Some of what we did in Paris was trying to get beyond old models of thinking, which were many people called top-down models of diplomacy, where the ultimate goal was to change the behavior of firms and state-owned enterprises. People often forget the energy business is globally actually mostly dominated by state-owned enterprises, so we probably should be doing more work understanding how policy affects the behavior and investment patterns of state-owned firms and not just privately held firms, an area where I work. Our lab does a lot of work. There's an integrated international treaty framework, and we need that because this is a global collective action problem, and therefore we need global action that's coordinated in various ways that runs through national policy. And that was the original logic that led to the Framework Convention on Climate Change, that led to the Kyoto Protocol, and I believe was beautiful theory that was completely irrelevant to the real world, where countries could pick and choose which commitments they wanted, and so not surprisingly, international cooperation in this mode did not work. We spent more than 20 years on that problem, and I think much of that time actually was not effectively used. So we're now engaged in a variety of new forms of thinking about climate cooperation. I just want to point out that the atmosphere hasn't not yet actually noticed we're doing this. If someone from another planet were to arrive here and inspect what we're doing, they would see us going to lots of conferences, some of us by super yacht, the rest of us by plane. But they would then look at the atmosphere and they would look at the oceans and they would not actually see any statistical deviation from previous trends. Some really interesting work underway at Cicero and some other places trying to develop these detection models, but when you look at the atmosphere, this is a Lowcarbon project work, organized big role for Cicero in this. Emissions last year are up 2.7% per year. We don't see actually any evidence that the emissions patterns have noticed. And those of you who would like these slides, I'm happy to make all the slides available so you don't need to take pictures. You can just ask me for them and I'll give them to you. My group, or my colleagues at Scripps Institution of Oceanography run this long-term monitoring station on top of Mauna Loa, a volcano in Hawaii, which I am convinced is an excuse for my colleagues to go to Hawaii and surf regularly, but they tell me that's not the case. When you look at that record, spliced with the ice core record, what you see is an acceleration in the uptick in measured carbon dioxide in the atmosphere. It's from a paper a few of us had in Nature late last year, where we took a look at the new IPCC 1.5 degree report, and we reanalyzed the underlying assumptions in the climate models that go into that report. Our conclusion was that the linear assumptions in the IPCC report were incorrect, and that we're starting to see an acceleration of warming. I believe this is now a mainstream view. And that's for a variety of reasons, including the rapid removal of the masking effect of sulfate aerosols, in particular from abatement in Asia. So I'm not saying people should stop abating sulfur emissions from coal plants in Asia. What I am saying is that when you put the whole picture together and you look at the interactions of some natural cycles in the atmosphere, along with the demasking effects, that you see an accelerated warming picture that is more consistent with reality. That tells us that goals like 1.5 degrees are going to arrive faster than people had originally thought. And when you take a step back from all this as a political scientist, you see no evidence that the atmosphere and the ocean system actually knows that we can go into all these conferences. And that's disheartening, because when you look at other areas of international cooperation, you see a totally different story, of which the most famous example is the Montreal Protocol on the ozone layer, where we have emissions. These are normalized emissions of chlorofluorocarbons. So there's total volume here. You see natural levels, background levels of emissions, the human emissions. Up until the 1970s, the discovery of the original chemistry that around the destruction of the ozone layer. A few countries adopt some bans on some products, and so total production consumption goes flat, and then demand catches up, and then up here we have the Montreal Protocol, and then right down the back as a result of the Montreal Protocol. So when people look at these histories of other areas of international cooperation, and what we did in the 90s in collaboration with Friedrich Nansen Institute was to look in enormous detail at cause and effect relationships of that. What you see are all these examples where countries got together, they worked on a problem, and then very quickly there was some kind of response to that problem, of which this is maybe the most striking example. And one of the reasons this example is both encouraging but also disturbing is that many of the lessons that people took from the Montreal Protocol experience and applied directly to climate were in fact the wrong lessons. that we went back in history and we saw this, and we said, well, the answer is we need an integrated top-down treaty framework with clear targets and timetables, and then the world will respond. What we didn't understand is that actually at the time, we knew from an industrial point of view, innovation point of view, and actually from an atmospheric point of view, a lot less about what was causing the problem than people understand. It's actually most of the reason the Montreal Protocol worked is because it created incentives for experimentation to go find alternatives. Fortuitously, that experimentation worked very well, and people learned very quickly, and we could then diffuse successful lessons. And part of the project that I'm going to talk about this morning is an effort to go back in history and understand actually how many of our experiences in international cooperation are of this experimentalist nature, where there's a commitment to do something, but actually nobody really knows what to do. And if we really internalize that logic, that would lead us to use the Paris framework, which is a good framework, in a different way. And that's the theme that I'd like to develop this morning. The geophysical and the socioeconomic data make it very clear that we have not yet made much, any close to zero epsilon progress this as a global problem. And that's not surprising, because it's a hard problem. The structure of the problem, I think Arnold used the phrase a long time ago, and the rest of us said, that's right, it's a malign problem. It's got an underlying economic structure that makes the politics really hard. And the key to fixing a malign problem is to change the underlying structure so that cooperation is easier, and that's where experimentalism comes in. And a lot of people look at what's happened in Paris and think of this as the opposite of what was done before, and that Paris, therefore, is a bottom-up treaty arrangement, or bottom-up set of agreements, rather than a top-down set of agreements. I think that's incorrect. I think actually we should stop using that language, because what's going to make it work is not pure bottom-upism. Pure bottom-upism isn't a recipe for chaos. It's for totally decentralized action, complete come and go as you please. My government is maybe the biggest example of this kind of irresponsible behavior. And the theories that we've been using to explain why bottom-up treaty frameworks will be effective are actually wrong. When you look at them closely, they're all wrong. And the real theories that are going to explain success in this area are different. And so what I want to do today is walk through 4 elements of that theory, that way of thinking about the world, and 4 implications of that theory for the discussions we're going to have later this morning, and maybe for even saving the planet along the way. And the theme that I'm going to develop is that Paris could work if it becomes an experimentalist regime, if it explicitly is designed and implemented in ways that encourage rapid, aggressive experimentalism. And there are elements of Paris that are going to be helpful, but we have to recognize that most of Paris actually can't deal with this, because it is anchored in consensus rules, more or less. And those of you who follow the rule book discussions very closely know the costs, mainly costs of consensus rules. We can all imagine clever voting schemes and other ways of getting beyond consensus rules, but those schemes are not yet relevant in the real world. So we have to think about real world strategies that use the framework of Paris, but then also figure out what needs to be done outside Paris in a way that is complementary to Paris. And that, in my mind, is the key way to think about this problem strategically in the international system today. So I want to talk about 4 things that are elements of a theory of experimentalist governance. This is based in part on a book that Chuck Sable, who's an industrial organization scholar at Columbia Law School, and I are writing. And in theory, later this week, we'll send the first draft to our publisher. Although, one thing I've learned, and my first big experience of this was with many of you in this room, is that writing a book is really hard. And one of the reasons there aren't more books in the world is it takes a few years after every experience to forget what it was like before you work on the next one. And so I'm ready to begin forgetting what this experience is like. But I want to talk about what I think we've learned from it along the way. 1, if you think about the climate problem geophysically, the atmosphere does not care where radiative forcing comes from. It does not care where carbon dioxide emissions come from. It's a global collective action problem with well-mixed pollutants, and therefore we should, in theory, think about this as a problem for which the geographical and industrial sources of the pollution are irrelevant, and all we care about is watts per square meter. It's all watts. That's true from a geophysical point of view, but it is not true from a political economy point of view, because the political structures that make action feasible depend on the countries in which they're in and the industrial sectors that they affect. And one of the things we've learned in moving from the top-down globalist view of the Framework Convention and the Kyoto Protocol to a more, what a lot of people are calling bottom-up view of Paris, is that one of the reasons that the country-led strategies of Paris, the nationally determined contributions, the pledge and review, whatever you want to call it, the reason that system is plausibly going to be more effective is that it allows countries and even industrial sector to define the problem the way they see it, and then focus action in a decomposed set of actions as opposed to a single, global, uniform set of actions. So we've known this for a long time. We've known this in part because not all countries are equal. Some countries are big emitters, some countries are small emitters, and so a lot of the logic around cooperation in small groups, clubs if you like, a lot of the club good cooperation theories were based originally on a fairly simple, correct idea that emissions are highly unequal in their allocation. It's a rank-order plot of carbon dioxide emissions from a book that I published in 2011, so I'm just kind of at the point right now of forgetting what that experience was like to get into another book, where we have the largest country here, which today is China. We'll hear more about China later this morning. Second largest countries, 1 and 2, together account for maybe 2/5 or more of global emissions. And so you can think about what a small group of countries might be that would engage in cooperation. One of the things that I think is very interesting is that when you look beyond just emissions, but you look at one of the major inputs into addressing the problem, R&D spending, one of the outputs of that, which is patenting activity or innovation, this is a proxy for innovation, patenting activity in energy-related technologies, what you see is an even greater concentration. This was the logic that led to the major economies and major emitters forum and the G7 getting involved in these kinds of activities, that you could get a lot done in small groups. My own thinking is evolved, and I think we need to be even more focused. We need to be focused on not just groups of big emitters, but also small groups that are focused with specific capabilities on pollutants for which they have a strong interest in doing something about it. This is work that we've done through the CSET project and earlier at Cicero. Marie Sand was here from the lead off of the first paper that we did in this area. There's a tremendous potential for making progress on short-lived climate pollutants, like soot that comes from diesel exhaust, like methane that comes from leaks in the natural gas system. This is an infrared photograph of the Elisa Canyon. This is a natural gas storage facility outside Los Angeles that leaked for several months and was the largest single source of pollution in California during that period of time. So there's a lot of progress we can make on short-lived climate pollutants. And what's really interesting about these pollutants is their political attributes. First of all, they're very powerful radiative forcers. Compared to the increase in radiative forcing on the planet that we measure today from carbon dioxide, short-lived pollutants may be about 2/3 the total amount of radiative forcing compared to carbon dioxide. So actually a big deal. They have short atmospheric lifetimes, which is why, frankly, most of our geophysical colleagues have ignored them because they thought this was a big global problem caused mainly by the long-lived pollutant, which is carbon dioxide. And while that's true for the year 2300, I'm worried about making progress in the next few decades. And so I'm less worried, sorry about this, I'm less worried about the year 2300, and I'm more worried about how do you create the political environment for making progress on the problem over the shorter term, and especially over the shorter term when we see very rapid rates of warming. And the answer to that are powerful short-lived pollutants whose attributes make them be felt earlier on. These pollutants also have this really interesting political attribute that they cause lots of other harm. Soot kills people directly. Methane in the atmosphere causes tropospheric ozone, which kills people and harms crops directly. One of the things that Stefan Kalvektin and I and some others have been doing is quantifying this. We have a paper out a year or two ago, another paper in the works, where you can look at the benefits to individual countries, including Norway, from direct focused action in small groups to address the short-lived climate pollutants. That's an example of how you decompose a big problem, which has these kind of woolly, abstract characteristics for which it's hard for countries to calculate national interest into states in the summary for policymakers. We tell the policymakers things about which we know a lot, and they also know that already. And we don't tell them very much about things for which we have very low confidence. We in the next report, and I guarantee we will fail, but we should try, we in the next report should do the opposite. We as a community need to talk more about the unknowns, unknown unknowns, the areas where we don't really know or for which the evidentiary basis is weaker, but actually the implications for policy design are more profound. And I think how we think about international cooperation is an example of that. And the fourth and last thing I'll say, and then we can hand it over to the rest of the panel, is the big test for experimental thinking will be the upcoming refresh on the nationally determined contributions and on the stock taking. What I expect to see in the next few years is a lot of talk about how the current path is inadequate. We've got to fill the gap. We need more high ambition coalitions. Everybody's going to be part of a high ambition coalition. When you fly to a meeting, you declare yourself part of a high ambition coalition, you come home, nothing happens. You can see a lot more slides like this. Thank you, Rodney, Andrew. It's a work coming fundamentally out of Cicero and the Lowcarbon project, where you see historical emissions, and then various scenarios out in the future as needed to stop warming at 1.5 degrees or 2 degrees, scenarios that are ridiculous because they can't be done. They involve 18, 20% reductions in emissions year on year. I think the French economy during the most rapid build out of its nuclear program achieved 4 to 6% reduction in emissions. So think of France, 3 times the speed of France globally, where nobody deviates from that. Not going to happen. So there's going to be a huge amount of kind of talking about this gap problem. That's a waste of time. What we should be doing in the next NDC, what I want to look for, what I'm keen to hear about, and people are going to talk about the other countries, is what does a high quality NDC look like? Which means information about not just what you're doing, but also what you tried, what's worked, and what's failed. And what are the commitments to experimentalism? Where and how are countries actually going off and investing, as Norway has done, for example, through the RED Plus scheme for the fund, with Brazil and trying in Indonesia and other places, some successes, some failures. Where are the actual experiments? What does that portfolio of experiments look like? If we can do this in the next round of NDCs and the stock taking, that will be demonstrable progress in the Paris regime. But understanding that requires looking less at Paris and more at individual countries, and that's what we're going to be doing right now. So thank you very much.